This is question number 9 of homework 4 for chapter 4. So again, this is a real-time data analysis exercise. The US Treasury issues some bonds as Treasury Inflation Indexed Securities, or called TIIS. Sometimes it's also called TIPS, TIPS, which stands for Treasury Inflation Protected Securities, but here it's inflation indexed securities, which are adjusted for inflation, and hence the yields can be roughly interpreted as real interest rates. So this comes from the Fisher equation we learned in this chapter. If you pull out my PowerPoint lecture slides, which is basically a summary of the chapter content, you can find the Fisher equation is I is the nominal interest rate, I subscript R, that stands for the real interest rate, and plus pi superscript E, that stands for expected inflation. So nominal interest rate is the sum of the real interest rate and expected inflation rate. Hence, if you go back to the setup here, the Treasury Inflation Indexed Securities, which are adjusted for inflation, so that refers to basically you deduct the expected inflation rate from the nominal rate, because basically what we can observe in the market is the nominal interest rate. So if you deduct the expected inflation rate from the nominal interest rate, then you get this real interest rate. So that's how we understand the first sentence. Go to the St. Louis Federal Reserve FRED database and find yield on the following 5 TIIS securities in order to compare them to their nominal counterparts. So the nominal counterparts are given later in the exercise, and this is for February the 8th, 2018. So in this table, you can see we have 5 series of TIIS indexes. So if you click on this, you can find this is one of the 5 indexes. So if you check the symbol here, that's DFII5, which is 5-year Treasury Inflation Indexed Security. And we have another 4. As we said earlier, you can simply copy this securities ID to this edit graph, add lines, copy here. So you can directly add that. And so from the chart, it's a bit slow to pop up the second chart. But now you see you have 2 charts available on the same, 2 graphs available on the same chart. And you can continue to add more lines following this symbol here. The third one is 10-year TIIS. So 10-year Treasury inflation, that's the first one. And add the third one. Again, probably have to wait a little bit. I guess the reason is because this is the daily observation, so it has a large amount of data, so it needs some time to process. And then continue to add the 4th graph, the 20-year TIS. And again, wait a little bit. So now it pumps up, and add the final series, which is 30-year TIIS. Okay, so wait for a bit. And then we can close this box. So now we have 5 graphs on the same chart. And then let's go back to the question. Following the Great Recession in 2008 to 2009, the 5, 7, 10, and even the 20-year TIS yields became negative for a period of time. How is this possible? So if we go back, so this is actually a little bit closer to the current time, so we need to move this to an earlier time period, 2008 to 2009. So this is a bit slow. Again, this is because this is a daily observation, so it has a large amount of data. That's why it might need some time to process. So now we are the time series is between 2008 and 2018. So and oh, actually, this is not very. So we probably oh, the 30 year is broken somewhere. So so I guess we need to extend the time period beyond 2008, 2009 to see the negative real interest rate. Because if you just say that between 2008 and 2009, actually all the numbers seems to be positive. But if you check the graph between actually 2010 and 2011, and even beyond that, we see a lot of negative numbers. So the question, I guess, may have some typo there, 2008, 2009. But in general, we can answer this question even without looking at the chart, because basically the question is asking why it's possible to have a negative real interest rate. Because the real interest rate, as due to the Fisher equation, is the nominal interest rate minus the expected inflation rate. So the reason we can have a negative real interest rate should be that the nominal interest rate is less than expected inflation rate. So multiple things could happen for that result. One is the nominal interest rate could be very small and the expected inflation rate could be very high. So let's see whether any answers can match that possibility. So A here is very high demand for TIIS to protect against inflation, increase the prices for TIIS. So this first part of the sentence makes sense, right? Because if the demand for the securities go up, and then investors more investors will be enticed into that market, so the price will be pushed up. Hence, but from this chapter, we know that price and the yield have a negative relationship to each other, right? The yield, the maturity, and the price, they have a negative relationship to each other. So if the price goes up, the yield, which is the interest rate, and that's the nominal interest rate, will go down. And so the where yields on TIS became negative for a period of time. And because the expecting inflation could be high, and that's in the first place, which drives the high demand for TIS. So if your nominal interest rate is going down because of the mechanism we talk about, price is pushing up, hence the yield is going down. But the expected inflation rate actually is going up. So there's possibility that the difference between this one and this one will become negative. So actually A is possible. So we can just choose A. Check my answer. Excellent. Why don't we also look at other choices? Market participants expected the inflation rate on average to be higher than the real interest rate over that same period. Thus, the nominal interest rate, as represented by the difference between the Treasury and the TIS yields, was negative. Actually, this is incorrect because the real interest rate is what this TIS yields represent. So this is incorrect. C, very high demand for TIS to protect against inflation decreased prices for TIS. So this first part of the sentence actually is incorrect because if the demand is high, more investors will be driven to buy securities, hence the price should go up, not going down. And D, A and B, because B is incorrect, so D is also incorrect. So that means only A is correct. For each of the bond pairs given below, record the TIS yield and calculate the difference between the nominal and the TIS yields. So this is at which time point? Again, let's go back. That's at February the 8th, 2018. So let's put our mouse to that time point. I believe it's at the last time point on this chart. So it's, you have to be a little bit careful sometimes. This sometimes can be a little bit sensitive. Now you can see that the 5-year Treasury inflation indexed security, the yield is 0.68. So now let's go back to the .68. So their difference, you can calculate that 2.57 0.68. So that's 1.89, 1.89. And then let's go on. Okay, so 7 years, that's 0.76. 0.76. Why don't we finish the table, then we calculate. 10 years is 0.76. So there's no difference here. 0.76. 20 year, that's 0.89. 0.89. And 30 year, that's 0.99. 0.99. Okay, so now let's calculate that. The difference obviously here is 2, and the difference here is 2.09, and the difference here is 2.14, and the difference here is 2.15. So now let's check our answer. Again, how did I come up with these numbers? Just take the difference between the nominal interest rate and the TIS, which is the real interest rate, and the difference is the expected inflation rate. And why is that? That's based on this Fisher equation. So if you move this IR to the left, and then the pi superscript E equals I minus I subscript R, and that's how I came up with those numbers. The difference between the nominal and the TIS yields for each pair represents expected inflation rate according to Fisher equation. And final part of this question, based on your answers above, are there significant variations in the differences in the bond pairs? Interpret the magnitude of the variation in differences among the pairs. So the difference, as we said, is the inflation. So if you observe this time trend, so for the difference, the inflation, you can see that it actually gradually goes up with the lengthening of the maturities. And the difference, which roughly represents inflation expectations, A, falls slightly as you move farther out, and that's not true. That increases. B, falls significantly as you move farther out. This is also not true. C, grows slightly as you move farther out, implying that market participants expect average inflation to be somewhat lower in the near term. And this is actually correct, right? Because the reason why it increases over time is because the lower maturity bonds investors expect those bonds to, the expected inflation over that time period, which is shorter, will be lower. You can see that that's 1.89 over the 5-year, and relative to the above 2 for the future, for the longer time spans. So, and this is correct. And let's finish the 4 choices. D is fairly constant over the various horizons. Again, this is incorrect. We observe an increase in inflation, expected inflation, with the increase of the bond maturities. So let's check our answer again. Excellent.